How's it going, guys? And in this video, we're going to be talking about the ways in which statisticians define and categorize types of variables, because variables come in many shapes and sizes, and we need to know what types of variables we're working with so we know what types of statistical analyses we can do down the road. And so there's four types of variables I'm going to be talking about in this video that are pretty comprehensive. We're going to be talking about categorical nominal variables, categorical ordinal variables, numerical ratio variables, and then finally numerical interval variables. And so you'll see how these things kind of build on top of each other. So the very first thing we're going to look at is this thing called categorical nominal. And so it's probably the most generic and non-numeric way of us defining variables. So a great example of this would be our types of blood. So people have A, B, O, we've got tons of different types of blood, and there's really no numbers associated with this. This is talking about the proteins that are on the surface of your red blood cells. That makes a huge difference here, but there's no number that really maps to that. So when we are labeling things and defining these variables, when we're talking about a particular set of variables like the proteins that make up the surface on your red blood cells, we rely on these things that are called categorical nominal variables because we're basically arbitrarily assigning a name to them. Like we're saying that this particular protein, we're going to call it type AB positive, for instance. So that's an example of that. And we don't really care about the order. So there's no preferential like AB plus is better than AB minus or anything like that. There's still no numbers there. So taking this up a level and looking at an example where we're dealing with a categorical ordinal thing, we can look at something like stages of cancer. So we have stage 1, 2, 3, and 4 for cancers. So we've arbitrarily decided to call whatever that episode is stage 1. So we've given it a number, but it's very arbitrary. In another universe, someone could have assigned that the number 5, and then it would go from like 5 to 9 would have been the stages of cancer in that universe. So still pretty arbitrarily assigning like names or numbers to things. But what we do care about and what sets us apart is the fact that order matters in these cases. So in these cases, like with stage 1, 2, 3, and 4 cancer, it does make a really big difference to statisticians and to doctors, and it changes the types of statistical testing we can do. So these are called ordinal because order matters in these things. Even though we've arbitrarily assigned numbers, it still matters. And another example of this would be like what place you got in a race. So like people strive to be first place and second place and third place. But at the end of the day, in another universe, we could have set 10 to be the place that you want to get, not place 1. So again, another example of how order does matter and that we are kind of arbitrarily assigning numbers to things that don't really have numerical values. So now we're going to go into the things that actually do have numerical values. And the next one we're going to be talking about is called numerical ratio. And so what does numerical ratio mean? So numerical ratio, the key thing to take home here is that these are these are variables that actually have numbers behind them. So like how much do I weigh? That's something you can tell. Like I can tell you I'm 145 pounds. And so like what comes out of this knowing that number? So the key thing to make note of is that with these numbers, with specifically the ratio, the numerical ratio types of variables, is that these things are not possible to go negative. You can never go negative with these types of numbers. So it's just like, can I have negative weight? Can I have negative height? So that is something that's not possible. So that's the reason why, if you're talking about height and weight with someone or volume, things that are definitely not possible to be negative, then the types of variables that a statistician would call them would be numerical ratio numbers or variables. And then finally, what we're going to talk about is numerical interval numbers. And so the classic example of this is the Fahrenheit scale. Why? Because in the Fahrenheit scale, we know that on a really cold day, it can be -20. And so it is possible to have negative temperature, but that's really not possible. So we are kind of making it even more inclusive here to say like with the numerical interval types of variables, you're allowed to have these negative things, and 0 really doesn't actually mean 0. It's just 0 degrees Celsius really actually means 273 degrees Kelvin. So Kelvin would be a great example of a scale that is ratio, and the Celsius would be an example of one that is the interval, because you can have 0 degrees Celsius but that doesn't mean, but you can still go negative. And so that whole going negative thing is something that only happens with intervals. So intervals include that kind of negative values that you could get from your numbers. So I'm hoping that this video is helpful for you guys. Let me know if you have any questions. Thank you all for watching. And a little bonus at the end here is we'll talk about discrete and continuous variables. So discrete ones are the ones in which there are things like whole number integer things. So like I can only have 2 apples. I can't have 2.5 apples. I know you can cut one, but for the sake of this example, you can only have 2 apples. Like you're not going to go to the store and buy 3.6 apples. You're going to go to the store and buy 3 apples. Whereas a continuous thing is something that can take on a range of numbers. And so an example of this is going to be something like your weight, where your weight, it is bounded, but it can take on a huge variety of numbers, and these are not things that are necessarily discretized into these boxes. Like, am I really 150 pounds, or am I 150.12 pounds, or am I 150.1234 pounds? Like, these are examples of the types of numbers that are more continuous that we deal with. So I hope this helps. Thank you all for watching, and I will talk to you guys next time.